Yesterday we talked about the putting together, not talked about, but we put together our unit circle. And up until this point, you guys should have on your unit circle 4 colors of bow ties, I'll say. Blue, yellow, and then green. What we're going to do now is we're going to actually fill this unit circle in with the appropriate measurements and coordinate points that the unit circle creates. So if you have not done this already, which I think you did yesterday, I want you to draw an X and Y axis on your unit circle. So if you've not done that, your x-axis horizontally, your y-axis vertically, going over the center of that. Obviously, we've got little bumps there. And then we're going to fill in the degree measurements. So on our unit circle, off here to the far right, we know that to be 0 degrees. Straight up, we know that to be 90. Off to the far left, we know that to be 180. And straight down below, we know that to be 270. And then if we make a full circle, we have come 360 degrees. Okay, so we have our degree measurements on there. When we created our green circle, that from the center point, the central angle, the green created a 30 degree. I'd like you to mark that if you have not already. Then we fold our flap down. The yellow created a 45 degree, and then fold the flap down, and the blue then created a 60 degree central angle. Something that I don't think that you did yesterday is create a perpendicular line, because we're going to take these color and we're going to actually create them into be a right triangle. So from where the color meets the edge of the circle, you're going to draw a perpendicular line straight down. That is creating a 90 degree angle. And then we're going to have our 30, 60, 90 degree triangle that we're going to be working with. Do the same thing with 45. Creating a right triangle. And then do the same thing with the 60, where it meets the top of the circle. And so these are our 30, 45, and 60 degree triangles that we have been working with up until this point. You have a note sheet at the top of it that says right triangle trig, and it looks like this for special right triangles. And if you could get that out, that will be greatly helpful. Because on the first part of the special right triangles, this would have been last week, you would have received this. We are finding the sine, cosine, and tangent of 30 degrees, and then we're finding the sine, cosine, and tangent of 60 degrees. And then on the back side, we did the same thing for 45, and we already created that, and that's what we're going to be putting in on our triangles here. So we know that if this is 30 degrees, the side opposite of that is our short side. And then the side adjacent is going to be our horizontal, our x-axis, and the hypotenuse is actually going to be the diagonal that goes out to the circle. And on a unit circle, the reason why this is called a unit circle is because from the center out to the circle, every distance, we call that the radius, each one of those is a unit of 1. So you can go ahead and mark on each one of these hypotenuse a unit of 1. That is one measurement. That is one measurement. And so if I have the hypotenuse is 1 to go to the short side on a 30 degree, 30, 60, 90 degree triangle, if the hypotenuse is 1 to get to the short side, I divide by 2. So this length is 1/2. Then from the short side to get to the medium side, I multiply by the square root of 3. So this distance is square root of 3 over 2. And what we just did there is we found, and I used the word distance. The distance from this central angle out to the edge of the circle is 1. The distance from the x-axis up to the top of the circle is 1/2, and the distance from the central angle out to the right triangle, the edge of the right triangle, is square root of 3 over 2. We're going to do the same thing then for our 45. We know this distance to be 1, and to get to a 45, and you can use your cheat sheet on this if you need to, but to go from the hypotenuse over to the, we'll call it the short side, but both of these are equivalent lengths on a 45, we would be then dividing by the square root of 2, so that is 1 root 2. And then this leg also would be 1 divided by square root of 2. We look at our 60 degree. The bottom part of this triangle would be my short side because that would be opposite the 30 degree. And just like what we did here, we're going to have those same measurements. They're just going to be flipped. So the hypotenuse is 1. To get to the short side, we divide by 2, so this side becomes 1/2. And to get to the long edge, we're going to take that and multiply it by the square root of 3. So this becomes square root of 3 divided by 2. So what we've just done is we've created a triangle, our 30, 60, 90 degree triangles, 45, 45, 90 degree triangles that we saw and actually we just quizzed on last week. Go ahead and make a little tick mark out here at the edge of each of the colors. At the edge of the green, we have 30 degrees. At the edge of the yellow, we have 45. And at the edge of the blue, we have 60. So I'm going to just go ahead and mark that just so that we know without having to go back and look and flip down. A couple things that we need to know before we finish filling in our unit circle is that when we go to plot a point on a grid, the first value that we plot, we go over on the x-axis, and then we go up a certain value on the y-axis. So we know that when we plot a point, it is x comma y. And when we convert this into a unit circle, the x becomes my cosine, and the y becomes my sine. So when I go to plot a point along the unit circle here, I know that the x value is the cosine value and the y value is the sine value. So to find what point this is right here, I'm going to do my distance across, which is square root of 3 over 2, and my y value, which is 1/2. And if you look at that, this is my cosine, because cosine, if you remember our SOHCAHTOA, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So if I do cosine, which is my first value, which is my x value, I'm going to take the square root of 3 over 2, which is adjacent, over hypotenuse. So square root of 3 over 2 over 1 is just square root of 3 over 2. Same thing with the sine value, which is my y. I'm going to take 1/2 over 1, which is just 1/2. I will do the same thing for 45. Cosine of 45 is adjacent over hypotenuse, which is 1 over square root of 2. The sine is exactly the same, 1 over square root of 2. 60, again, is the x value comes first, which is cosine adjacent over hypotenuse, and then my sine, which is square root of 3 over 2. So I now have just created the points that if I was to graph this, I would go over square root of 3 over 2 and then up 1/2 to get to the point at the edge of that sector making the 30-degree angle. Same thing here. I'd go over 1 over square root of 2 and then up 1 over square root of 2. And for 60 to get to this point, I'd go over 1/2 and up square root of 3 over 2. And one thing that I failed to do was to go and put in our obvious points, knowing that the radius here is 1. At 0, I have 1 comma 0. At 90, I have 0 comma 1. At 180, I have negative 1 comma 0. And at 270, I have 0, comma, -1. Because we know in this quadrant, we have everything that's positive. In the second quadrant, our x value is negative, but our y value is positive. In the third quadrant, our x value is negative and our y value is negative. And in the fourth quadrant, our x value is positive, but our y value is negative. So applying that, over here then, we know that our cosine is going to be negative, but our sine value will be positive because I just said that the x value is negative and the y value is positive. In the third quadrant, I said that the negative cosine and negative sine, which translates opposite of x and the opposite of y. Both of the x and the y values are negative. In the fourth quadrant, my x value is positive, therefore my cosine is positive, but my sine will be negative. And that translates to a positive x and a negative y. So the remainder of the class period, I would like you to, the reason why we did the colors is you're going to notice that the 60 degree here is going to translate into the same degree over here on this blue, along with this same down here and also down here. So let's go ahead and fill in before we get going any further. Let's go ahead and fill in the rest of these angle measurements as we go through. So if this is 60, we count to 90. This becomes an angle measurement at 120. This is an angle measurement at 135 degrees. And this angle measurement is at 150 degrees. I just took 90 plus 30, which is 120. 120 plus 30 gave me 150. 150 plus 30 gives me 180. 180 plus 30 gives me 210. 210 plus 30 gives me 240. 240 plus 30 gives me 270. 270 plus 30 gives me 300. 300 plus 30 gives me 330 degrees. 330 plus 30 gets me back to 360. To fill in my 45s, my yellows, 0 plus 45, 45. 40 plus 45 is 90. 90 plus 45 is 135. 135 plus 45 is 180. 180 plus 45, we'll fill in this new one, is 225. 225 plus 45 is 270. 270 plus 45 is 315. 315 plus 45 is 360. So the remainder of the time now, I would like you to fill in your cosine and sine values. So for instance, and I'm going to use blue because of blue, and I've got orange for yellow and green for green. My values are not going to change except for the sine. So when it's blue, I know cosine is going to be 1/2. But the question is it positive or negative? If I'm in the second quadrant, I know the cosine to be negative. So that's going to be -1/2. The sine is positive, square root of 3 over 2. Down below, in the fourth quadrant, it's blue. So I know my cosine is going to be 1/2. My sine is going to be square root of 3 over 2. But in the fourth quadrant, I know that they're both going to be negative. So this is going to be -1/2, negative square root of 3 over 2. In the fourth quadrant, I know that the cosine is going to be positive and the sine is going to be negative. So this is going to be cosine is 1/2, sine is going to be negative square root of 3 over 2. So go ahead and finish the remainder of this unit circle. Yellows stay with yellow, greens stay with green, but watch your signs whether it's going to be positive or whether it's going to be negative in that unit circle. And then we will finish up looking at tangent on Thursday.